Well, hello again, Workplace 20 students. Excited to present to you Chapter 2.2 Bar Graphs. All right, so let's take a look. What is a bar graph? Well, a bar graph is a graph that uses horizontal or vertical bars to display data. And we'll take a look at that a little bit, but basically you're thinking about bars that are going this way or bars that are going this way. All right, so when you take a look here, at the information in this first example. All right, again, here's some data that was given to us in a table form, and again, the first information here, that's going to go on your x-axis or your horizontal axis. All right, this right here. I'm trying to get my highlighter. There we go. Right, whereas the second row, number of callers, that's going to be your dependent variable and will go on your y-axis. Okay, so what scale would you choose for your vertical axis? So when we take a look here, we have this low of 12, but we have a maximum of 180. So we're not going to go past 180, so very much so. That's why I will pick 200. All right, so when we do the scale, right, it's really important that if you have to count, like, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's about 12 blocks we can go up, right? So if we choose a scale of 20, it will fit in nicely. And when we look at our data, yeah, 20 would be a nice way to be able to do that. So basically, you're thinking that, even if you went halfway up on a block, you're looking at like halfway up would be 10, right? So that works out well in this case. All right. So you can see here, again, we labeled our x-axis, that's our independent variable, and we labeled our y. Now it's a little bit, came off a little bit, but again, what you should put here is number of callers. You got to make sure you put that information in. And again, you can see that we have our title. All right. So when I looked at the data here, you can see that for internet it was 97, so it almost went up to the 100 there. So you can see we have a nice vertical bar graph there, and then so on. So you can see all the way down to 12 for other and 17 for TV. But you can definitely see by looking at this the drastic and make some choices between like TV and print ads and see what you're going to go and where people are finding it, their information. So this is really useful if you're doing an advertising campaign where you're going to put your monies into for sure. All right. So again, well put together, makes sense to me. And we take a look at our scale. We talked about that. What would be an appropriate title for the graph? Again, you can see where people found their call center information. Right. So that's how we came up with our title. All right. So we can take a look here. And another thing you can do here, you see these sometimes, but you can also, in this case, you can also show your bar graphs horizontally. All right, so you can see here, like the city, this would be this one here, it'd be going horizontal, and the highway is in green in that. So it has a nice legend. It's got a title. Again, now this is, like I said even before, there's always sometimes some exceptions, but now you on this is kind of like your x-axis here. It's kind of flipped on its side because we're going horizontally. So you put your cars down there, car A, B, C, and D, right? Those will be your independent variables, and then how much liters per 100 kilometers it used is going here. And you can also compare the city to the highway. So this is actually known as a double bar graph. So you can see here where it took like city for car A. Again, look, each block to use a scale of 1, but they didn't go 1, 2, 3, 4. They just went every second one to make sure there was some space. There's nothing wrong if this would have had 1 and this would have had 3 and this would have had 5 and so on. All right, it's just when this was made, just went by every twos. And you can kind of take a look here at the data and see why that would be able to do that. All right, so everything's labeled properly. It's drawn, easy to find things. All right, and now that we have it drawn, we can use that to figure out information. Which car would you buy based on the fuel consumption one, right? Well, it looks like car C is really good in the city, but car D looks a little bit better on the highway, right? If you take a look at that. So I would probably, it depends what you're doing, right? Would you drive more? If you're doing a balance, you can take a look, but if you're doing more highway, definitely looks like car D is better. If you're doing city, definitely looks like car C is better. So again, you'd have to make the call on that one. All right, so again, we can take a look at marks and see how people are doing. Ms. Runson posted a graph on her notice board. I wouldn't do this, but it's all right that she did this for what we're learning now. Again, you can see here that it's labeled as a title. It's labeled on the y-axis, and it's also labeled on the x-axis. All right, so what does the graph tells you? It tells you how many students earned how many points on a quiz out of 10, right? Here it is, out of 10, and then you can see the number of students, and they either got 1 out of 10 all the way to 10 out of 10. Nobody got 0 out of 10 on that too, so that's pretty good. How many students wrote a perfect paper? Well, when you take a look here, there is 1 student. Okay, and again, I wish I had a straight line going there, but the scale here is 2. Halfway up 2 would be 1, and you can tell that you wouldn't have 2.2 of a person, right? So we can assume that each of these are increment by 1. What is the most common score? Well, what's the tallest bar? Oh, it's right there. It goes with 7. So that's how we pick 7 out of 10. How many students got 0? We talked about that already. 0. How many students wrote? This is interesting because I go like 1, right? So you can see I've got 1 there. There's 1 there. There's about 4 there. 6, 12, 2, 3, and 1. When you add together, 30 students wrote this test. All right. All right, so again, this is another double bar graph that we're taking a peek at here. Again, it has a title. Again, it's labeled its axes, which is good. Here you have your legend for boys and girls, and now you can start to figure out some things. This is one little point of note, right? When you see this, remember I talked before about scale and kids starting at 66? Well, you can see if you have this little squiggly line here, right? It almost looks like a heartbeat. When you start there, it shows that, okay, everybody had 64. So we're looking at what's 64 and up. You couldn't go 0 to 66 and then go by 2s. You have to have the proper scale. So this is a really important little piece. If you have some data where they all share like 10 or 20, you can start at 22 or whatever, but you have to show on that. And when you look at this, do you disagree with Kay's conclusion? All right, justify your response. So Kay thought here the graduations of boys and girls at 3, she concluded that the girls have a better graduate than the boys, and that school B is much better based on that. So when you look here, I would say that definitely the girls are, having a better graduate. I would agree with her on that. And school B, right, is much better school based on its graduation. Well, you can't say without the populations of the schools and that too, and what it's made up about. And it's tough what makes a good school or not, right? But it's interesting. What are the graduation rates? Again, you can see school A, about 69 there. And you can see for the boys is 68. So it's really easy to read this graph and pick up what you need to get out of it. All right, so thanks a lot for watching this. Again, you can do the assignments on page 96, 1 through 4 on there in your workbook if you have that available. Please do the formative. Jump on the Flipgrid and tell me some of your questions and things you're learning, or send me a remind, or jump in the form and just do that. So thanks again for watching.